Hello, ladies and gentlemen. Today is our very first video, Shapes and Designs 2.1. That's Investigation 2, Lesson 1. Now, the lesson for today is on page 28, and the lesson will be problems A through C, and then we would like you to do the ACE problems found at the end of the investigation, problems 1 through 9, and then 27. Okay, so do 1 through 9, and then skip ahead and do problem 27. And our learning target for today is that you can identify the parts of an angle and basic angle benchmarks. We'll get into that very quickly. All right, the very first thing you're going to want to do is make sure you take out a fresh sheet of notebook paper. Do not tear it out of your notebook. Please make sure it's a fresh sheet. Okay? It should have nothing else on it. It should only be used for notes. And how will we know it's notes? Well, at the very top, we're going to write Lesson 2.1 Notes. And it might be a good idea to write it nice and big, maybe even underline it. And in the right-hand corner, we're going to make sure we include our name, our date, and the crew. And the reason we include the name, date, and crew is so that if you lose this, we can find you. We know what day you wrote it on, so if we want to kind of go back and remember what we did 2 weeks ago to kind of gauge our progress, that'll be available. And if we lose it, I know very, very quickly, without having to look it up, which crew teacher it needs to go to. And the other important thing we want to include in here are the page numbers in the book. So we know in our textbook where we got these notes. Okay? So make sure you have all of these things before you continue. Pause the video if you need to. All right, with our notes ready, we're going to go ahead and insert our first set of notes. Now, here's how we're going to do notes. In nice big bold letters, we're going to write angles. And that's just the basic theme, the header of what we're going to be writing about. And the very first thing we're going to want to do with angles is mention what an angle is. And an angle is the amount of turning. Okay? There are fancier ways to describe it, but it is the amount of turning found when two intersecting lines intersect each other. Well, when two lines or two rays or two sides of a shape cross each other, how much of a turning is there? How much of a degree? How steep is it? And we want to include that this is measured in degrees, where 0 degrees is no rotation. Okay, no rotation. And 360 degrees is a full rotation. Okay, and I might even include a little doodle here for my benefit, where if I go entirely around, that is 360 degrees. Okay, a complete rotation. Those of you who are snowboarders or skateboarders, you probably already understand what a 360 is, or a 720 is, or a 180 is, and things will look very good for you. And I'm just going to write down underneath it, and I'm going to indent for my examples. And my examples are how much you turn a knob or a dial, right? If you need to turn a dial 35 degrees or 40 degrees, what does that mean? The steepness of a roof. If your roof has a 45-degree angle or a 60-degree angle, what does that mean? Or it can mean a wedge shape, like the amount on a slice of pizza. How much of a pizza is a 75-degree slice of pizza? How much is that going to be? What will that look like? These are all ways that we can describe angles being used. Now, you don't need to use my examples. You can come up with your own, but you should probably have 3 included in your notes. Go ahead and pause this if you need to take these notes down. All right, now we're on to notes part 2, and I'm going to have another heading here called parts of an angle. And in parts of an angle, we're going to name, well, the parts of an angle. And the first part we're going to name is a ray. A ray, also known as a half line. And a ray is a figure in geometry and math where we have a starting point, a beginning, but no end. Okay? Now, some of you might remember a line is a straight set of points going off in both directions forever. Well, a ray is exactly half of that. Think of a ray of light shining out from a laser beam, right? We know where that beam started, but in theory, it will never end. It will just shoot off into it forever in that same direction. And we have angles that are formed when two rays intersect. So I'm going to draw my angle here. I'm going to write that these are rays. And it's very important that we put in that a ray has a beginning but no end. You will use rays an awful lot later on in geometry. And then finally, we have a vertex. And a vertex is where two rays or two lines or two sides form to meet an angle. So the point where they meet is called the vertex. Okay? The vertex. And that makes it incredibly important. It's an incredibly important math term. Okay? When we say the angle, what we're really measuring is the amount of turning between those two rays where they meet at that vertex. Okay? A vertex is just a fancy name for where lines cross. And again, anything you want to add to these notes is perfectly appropriate. If there's something that helps you remember what a vertex is, go ahead and add that to your notes. Pause this again if you need to get these notes down. All right, now here's notes part 3, and my next heading is going to be benchmarks. Now, what are benchmarks? Benchmarks are, signposts. They're basically things that we have all agreed on are really good measurements. Think of benchmarks in real life. A gallon. We all know about how much a gallon is. Think about a foot. We all know about what a foot is. And there are good benchmarks and there are bad benchmarks. In angles, we tend to stick to some very basic benchmarks. There are 360 degrees in all these angles. However, we tend to describe angles based on 3 benchmarks. We will describe right angles, and a right angle is exactly 90 degrees. Okay? Most of you remember that. And sometimes we will measure, when we show an angle and we put a little box in the corner, that is to prove, it's sort of a shorthand, that this is exactly 90 degrees. Okay? They may not they may not say that it's 90 degrees, but it's there. And an obtuse angle is an angle larger than 90 degrees. Okay? It's anything that is 90.0001 degrees or larger. If it's bigger than 90 degrees, it is obtuse. And then we have an acute angle. And an acute angle is less than 90 degrees. And I like to think of acute angles as they're so darn cute. An acute angle. They're tiny. Think of a slice of pizza. Think of the wedge in an axe or a doorstop. These are all acute angles. Okay? And those are just the important benchmarks we want to get down. Because from here on out, when we describe angles, it will make things a lot easier if you understand these very, very well. So make sure you get these notes down, and again, put down any examples or any extra notes you feel you need. Pause this if you need it. All right, now we get to our coursework. Now our coursework, we're going to want to have a fresh sheet of paper. We do not want this on our notes. Okay? Pick the next sheet of paper that is free and clear of any kind of doodles, any kind of notes, any kind of anything. You want to be able to tear this out and hand this in if I ask you to. We are going to label this Lesson 2.1 Practice. We're going to put page 28 and through 29 at the top, and we're going to include the name, the date, and the crew. And when we do our practice, we're going to make sure we have that nice big heading here where we write Lesson 2.1, page 28 through 29. That lets me know what part of the book you got these problems from. And we're going to start with A and 1. Now let's say there's A2. What we would do is we would just go straight down and put a 2 there and answer the question. This is an outline form, similar to an outline that you'd have in English class. And this lets you correct your work very quickly and find specific things you've written down very quickly. But your ACE problems are the exact opposite. You're going to have problem number 1, and you might have problem number 1, A, B, or C. But you want to indent from the 1. That way you can go right down the line and find exactly the answer you want to correct. Okay, go ahead and answer any questions that are at the end of this video, and either start the work or come to class prepared to work on it and ask me and your classmates some questions.